All right, so again, take a look. Again, take a look at your checklist. Make sure you know what we're going to get done this week. In black is in person, and blue is your digital assignments. Notice that you have 3 digital assignments this week. Now, depending on how busy the class has been outside of class, the other side of the alphabet will have blue text on the top, and that's what they're going to be doing today. So what I'm going to try to do is actually give you guys deadlines, and if you miss those deadlines, your grade will be impacted by missing deadlines at this point. Okay, so we're going to start off with like 10% per day. All right, so anyway, if you make 100 on something, you can still make a 90 if you do it a day late, kind of a deal. All right, I'm considering a less harsh punishment, but at this point, our team has agreed on 10% per day to try to encourage you guys to get some of these things done on time. Okay. Okay. So let's go on and flip into the triangle sum theorem and some special theorems about triangles. Okay. So the triangle sum theorem just says that the 3 interior angles of a triangle add up to 180 degrees. And basically it's an alternate interior angles thing. Do y'all remember 2 parallel lines and a transversal? And if you have alternate interior angles, that they're congruent? Nod your head yes or no. Yeah? Do y'all remember that? Okay, if you don't remember it, then it is displayed over there on that poster on the far side there. Okay, so basically, if I have a triangle, any triangle I can do this to, I can come up here to the apex of the triangle and just draw a parallel line. And what that parallel line will do is it will create alternate interior angles right here. This and this, right? So you can see that those 2 red angles have to be the same, right? Well, then I'm going to highlight this angle is an alternate interior angle with this, angle 3. All right? So what's the red one plus 2 plus the blue one? Have to be, if they all sit on a straight line like that, 180. Okay, so what we're saying is anytime you have a triangle, the interior angles will add up to 180 because you can do this with any triangle. All right, so let's take a look at what we'll do on the next few questions. What we'll do is just put an X anywhere you see a question mark, and that's basically the angle that we're going to be trying to find. And the theorem says that angle plus angle plus angle equals 180. Well, what are the 3 angles? Well, the 3 angles are X, 60, and 70. 60 and 70 make 150. So if I subtract them to the other side, I'll be subtracting 130, right? So if I subtract them to the other side, then I'll get X equals 50 degrees. Yeah. Am I saying that right? This is 130. Yeah. Subtract, you get 50. Okay. The next problem is the same deal. You have 3 angles inside a triangle. Those 3 angles need to add up to 180 degrees. So by substitution, I'm just going to say X, 35 and 75. This time I'll take the extra step and put these together by addition. So 110 it looks like. And I'll go ahead and show you the algebraic step by subtracting 110 from each side as well. You're growing up in Algebra 1 skills, so if you're not showing all of those steps, just as long as you're showing some or most of them to show that your thoughts are valid. Now don't just say X equals 70 and just be done with the problem. That's not acceptable, right? Okay. So we'll skip on to number 3 when you're ready. Hey Carter, can you scoot up closer or bring glasses, either way, but scoot up closer until you have glasses, please. If you could see, you would squint. All right, so in this case, we have angle plus angle plus angle equals 180. And there are 3 angles. Everybody agrees that there are 3 angles. I'm going to highlight all 3 of them in yellow. 1, 2, 3. Okay? So for this first substitution, I'm going to put in x plus 38 in there. For the next angle, I'm going to put in 60. And for the next angle, what do I need to put in? Well, this little box tells us that that is 90 degrees, so those of you who said 90, you're absolutely right. You'll put 90 in there. Now, you'll notice that in my template or my formula, it says angle plus angle, right? 3 angles. But look down here, I have 4 terms. Is that okay? Yes, that happens sometimes. Sometimes a substitution will actually have 2 terms in it. So this one angle was represented by 2 terms, and that happens sometimes, okay? So let's add the like terms together. 90 and 60 make 150. $150 and 38 make 188. We'll subtract 188 from both sides and get that x equals -8. That might seem kind of strange to you because x equals a negative number. But basically what that is saying is that this angle over here is just 30 degrees. 30, 60, 90 will add up to 180 degrees like normal. All right, and with no context, x can be negative. I don't know what x represents. I'll leave that there until I see that you're ready. Go ahead and attempt the next problem. No need to wait on me. So I left number 4 as a challenge to you guys, and you guys did a great job. You got x equals 12. If you did not get x equals 12, try to make some adjustments and try to figure that one out for yourself, okay? Starts off with the same template as we used in the other problems. Okay, so we're going to learn about the exterior angle theorem today. So before we start on the exterior angle theorem, we need to define an exterior angle. So an exterior angle of a triangle is formed by one side of the triangle and an extension of an adjacent side. Okay, one side and the extension of how many sides? One adjacent side. Maybe I should actually put the word here. One adjacent side instead of an adjacent side. All right. Now the remote interior angles for this one are angle 1 and angle 2. So angle 1 and angle 2 are the remote interior angles. And in this picture, you can't see it on the screen right now, but angle 4 is the exterior angle. All right. So here's what the exterior angle theorem says. It says that the measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. It's equal to the sum. So the measure of an exterior angle is equal to the sum of the measures of its remote interior angles. Okay? As a result, the measure of angle 4, this exterior angle, is always greater than the measure of angle 1. And the measure of angle 4 is always greater than the measure of angle 2. I don't think that that's going to pop up in any of our questions, but it does sometimes show up in curriculums across the country. Okay? So, so anyway, what we're saying is that if the angle 4, if it's equal to the sum of 1 and 2, then it better be greater than each of them. Kind of makes sense, right? All right, so let's pretend for just a minute, let's just put in some numbers. Let's say that angle 4 was 140 degrees and angle 1 was 40 degrees. How much is angle 2? So this one right in here is 40 degrees. This one out here is 140. How much is angle 2? 100. And the way you got that was you just had to make sure that those two numbers added up to 140. All right? So, let's do some practice problems together. The first thing that I'll do is I'll highlight the exterior angle when I do these kinds of problems. Okay, so the exterior angle in this case is the question mark. Okay? And then what I like to do is circle the two remote interior angles. The two remote ones are out here. Okay? So the angle, the exterior angle, equals two angles added together, and we just need to make sure that we put the right numbers in the right spots. So instead of a question mark, let's put X. So is X the exterior or one of the remotes? X is the exterior angle, so it will go in on the left side of the equation. And the two interior angles are 51 and 78. So in this case, there's no equation to solve, just two numbers to add together. It looks like 129 to me, and X represents the angle measure, so we'll put degrees next to that, 129 degrees. All right, all right. Okay, so number 8. What I will do is first take my highlighter and go highlight the exterior angle. And if you're just using a pencil or something, feel free to just circle it or something, right? And then I'm going to circle the two exterior angles. I'm sorry, remote interior angles. Actually, you know what? Let's talk about that for a minute. Why do you think they call those remote? Let's say I was sitting on the couch right here, and this is my TV over here. What do I need to change the channel? A remote. Yeah, so I need a remote. Okay, so the deal is that it's farther away. This angle, there is another hidden angle right here, this blue one. Let's call it the blue one, right? Is that angle in there a remote interior angle? Say no. No, that one's not remote. That one is called adjacent. Adjacent means that it's next to, it shares a common side, it shares a common vertex. There are no common interior points. Okay, so remote just means that it's not adjacent to. Okay, so now that we've taken care of that, we're going to write down our template and also define this angle in here to be X. So we know that the formula is exterior angle equals angle plus angle. But now we need to make sure that we put the correct numbers in the correct spots. So going from left to right, what should go in for exterior angle? Should it be X, 46, or 93? 93 goes in there. And then the two remote interior angles are both X and 46. And now we just have a simple linear equation that we can solve by subtracting 46. 93 minus 40 is 53. So minus 6 more. 47. So x equals 47. I should have probably said 47 equals x and then flipped it, but I think that you guys follow that logic anyway. Okay. So the truth about isosceles triangles. Let's talk about those. An isosceles triangle is a triangle that has, there's not enough space for this, but let's say at least 2 congruent sides. We don't see it often when there are questions dealing with equilaterals versus isosceles, but again, you'll see it across the nation, but you won't see it too often in this class. All right, so an isosceles triangle is a triangle that has at least 2 congruent sides. The congruent sides are called the legs. The third The third side is called the base. Okay? The angles opposite the base is called the blank. We'll call that like the apex or the, you know what? I'm not sure what word should go there. The angles opposite the congruent sides are called the base angles. You know what? Let's Google that real quick. Let's see where we go. After a little Google search, we found the angle opposite the base is called the vertex angle. All right. There we go. So let's draw a little picture and see if we can put most of those two, let's try to label it, I guess is what I'm trying to say. So what are those two sides that are marked called? A leg and a leg. And what is this, and what is this other side down here called? It's called the base. Okay, so these words on the left are turning into a picture now. Okay, the two congruent sides are called legs. The third side is called a base. All right, this will be the third side. So I'm going to use the highlighter, and I'm going to ask you guys, what is this angle up here opposite the base? Yep, that's called the vertex angle. That's strange to me because you have a vertex whenever you have two sides meet, but for whatever reason in an isosceles triangle they call that one the vertex angle. And then these two angles down here, what are those called? Those are called the base angles. Base angle. I guess I should just say base angle on each one of those labels. All right, so we just converted all those words into a nice little labeled picture. Okay. All right, so the isosceles triangle theorem says this: if blank sides of a triangle are congruent, so basically just if two sides of a triangle are congruent, then the angles opposite those sides, the angles opposite those sides are congruent. Now we kind of need to talk about the word opposite, don't we? Okay, so if here's a side, the word opposite means farthest angle away from it and not adjacent. It's right in here. People get this word confused with the word included. They'll say that this side is included in the angle, and that's wrong. This side is opposite the angle. All right? So, what is opposite angle, segment PR? What angle is opposite angle side PR? Angle Q. So angle Q has to be congruent to, well, what side is opposite of QR or RQ? Angle P. So we're just saying that the base angles are congruent. Okay? Actually, if I were to say it again, I would retype this and just say that base angles are congruent. So in an isosceles triangles, in an isosceles triangle, base angles are congruent. All right, and the converse just means that we take the hypothesis and the conclusion of this sentence and we switch them. So this time we're just saying that if the angles are congruent, then the opposite sides are congruent. So let's try to fill in the blanks here. If base angles of a triangle are congruent, then the sides opposite those angles are congruent. Sorry for the typo there. Then the sides opposite those angles are congruent. So what is the opposite side to angle P? Give me two letters. RQ, right? And then the side opposite of angle Q is side RP. Okay? Another way of saying this is that if the base angles are congruent, then the legs are congruent. But you have to know which ones are the legs. Okay? Legs are congruent. All right. So moving on to the next page, we deal with a few examples talking about isosceles triangles. Okay. So with an isosceles triangle, this one says that the vertex angle up there is 78 degrees. What we're going to be challenged with is actually finding angle C, it says. So we need to find that one. Well, how much is that one? The same as A, yeah. It's the same as A. Well, we know that by the triangle sum theorem that three angles add up to 180. And we know that angle A is the same as angle C. So if we're going to make a variable for this, what variable would you like to use? Typically, most people say X is going to represent angle C. Well, then you can use the same exact letter for angle A because they're the same. So now when we add these up, it's going to be X plus 78 is 180. X plus X, we basically add the leading coefficient on each one of those and have 2X plus 78 is 180. Doing a little bit of algebra, the next two steps would be to subtract 78 and then divide by 2. Okay? So when you subtract 78, you'll get 102. And when you divide by 2, you'll get 61. X represents angle C, so we're going to say that angle C is 61 degrees. Clear enough?
It's 51.
Ah, Oh, 51. Yeah, thanks. My bad.
Yeah, I was confused as to that.
Nope, that's me. All right, thanks a lot. Okay, so the next problem is going to be one of those that you do on your own, and I'll walk around and check on you. Yeah, so great job all the way around. You guys used your template exactly the way you should, and you guys got the x equals 47 degree, 47, and that x represents angle Q and angle P, but this question asks you for angle Q, so you would say 47 degrees. So great job. So finally, we're discussing equilateral triangles. Equilateral triangles have a couple of more properties that we'll need to add. So if a triangle is equilateral, then all the angles are equal as well, equiangular. If all sides are equal, then all the angles are actually 60 degrees. So this is an acute triangle, okay? Equiangular triangle, if it's equiangular, then it's equilateral. And if all the angles are 60 degrees, then the sides are equal also. They're not 60 degrees because sides can't be a degree measure. You're just saying that the sides are equal. So if the angles are congruent, then the sides are congruent. This also works the other way. This is bidirectional. Okay? So here we go. Find each value. Can we just agree that that says 50, even though the font doesn't?
Looks like 5N.
Wait, it can't be 50.
It's 5N.
5N?
Yeah.
Thanks. 5N. Oh, okay. That helps. So if that's 5N and all the sides are the same, then how much is 5N supposed to be equal to? What are all the angles going to be if it's equilateral?
60.
All the angles are going to be 60, so we're just going to say that 5N equals 60. Divide by 5 and you'll get 12. Some people are unsatisfied with that, and that's okay. What you could have done also is said that 5N plus 5N plus 5N equals 180. That gives us that 15N equals 180. Divide by 15 and you'll get 12 again. So not sure which one of those you like more. You probably like the one down here because you've worked it more, but eventually you should be able to see that equilateral triangles are going to give you 60-degree angles. Okay? Okay, what about this next one? Can you read it better than I can? 2x minus 6 or plus?
It looks like minus.
I agree with you. It looks like a minus. So how much should that be equal to?
60.
Yeah, so we're just going to say 2x minus 6 equals 60. So that 2x equals 66, and that x equals 33. And then the two that are dealing with sides, this says to find the length of VT. How long do you think it is?
18.
Probably 18. Is it 18 degrees?
No.
No, just 18. It might be inches, centimeters, anything but degrees. And MN, well, it says MN is 13, so I imagine that this problem, they should have said something like ML, okay? So ML, how long do you think that one is? If all the angles are the same, then the sides must be the same. So 13. All right, so I did my best in teaching you a lot today. I taught you the triangle sum theorem. I taught you the exterior angle sum theorem. I taught you the definition of exterior angle sum and the remote interior angles. I taught you how an isosceles triangle was made and a theorem that goes along with it, talking about the base angles and the legs. And then I talked to you about equilateral triangles and how all the angles are all 60 degrees and all the sides are the same measure or the same length, so they are congruent. All right, so there you have it. Hope you enjoyed the lesson, and we will get back together, I guess, in a couple of days.